A very warm good morning and welcome to everybody that has just joined today's session. I am behind the camera today. I know you're all used to seeing me on camera, but my colleague Arnold is on screen. Please let me know in the chat box if you can see him. Arnold, give us all a wave so that we can let all the attendees see that you're here. I just wanted to say thank you to everybody for joining us, particularly those in South Africa. I know that with the third wave and some of the other restrictions that have been put into place, our nonprofit clients are inundated at the moment. If you do know of an NGO or a colleague that was supposed to be on this event but can't today, please do let them know that we are recording. We will be sharing that out towards 3 o'clock this afternoon on email to those of you that RSVP'd. But myself and Dar in the chat box, if you would like us to send it to you on a different email address, please send that to us privately. So we're going to get started. It is 11:01 and I'd like to introduce Arnold Netshambidi. He is our Executive Director. You all know Arnold. I don't need to give him a big welcome. You speak to him all the time and he's going to get this morning kick-started. Good morning, Arnold.
Morning, Sam. Thanks so much. Morning, everyone. Welcome to, this is our second virtual nonprofit executive digital leadership series focusing on cloud cost optimization and management with, our great partner, Amazon Web Services. Today, we're joined by Eslyn Barents. She is the Territory Account Manager for the nonprofits here in Africa. She's also joined by her colleague who will be introduced shortly. If you were unable to join our first series, we have the recording which we can still share with you, just so that you understand the flow of all this leadership series that we are hosting for all the nonprofits here. We also have the ebook, which is available on download. Again, if you do need the ebook, we're happy to share it with you. So our first series, the first one focused on making the world a better place with Amazon Web Services. And again, as you all know, Amazon Web Services is one of our technology partner through the TECSO program. So if you do need more information, we're happy to assist you with all the credits. Again, so, without, wasting any time, please allow me to introduce, our guest for today, Eslyn Barents. Eslyn, welcome. Okay, I can see you now.
Arnold, and thank you, Arnold, and good morning, everyone. I am really excited to be with you today because I am super passionate about helping nonprofits on the cloud transformation journey. So I am from Amazon Web Services, also known as AWS. I am an account manager for nonprofits in South Africa, and I am based out in Cape Town. So if you attended the last session, I would have maybe seen you there when I presented an introduction to AWS for nonprofits. And today we are going to be delving into cost optimization, cloud cost optimization and management with AWS. So we are constantly working with our customers to help them reduce their IT cost and spend. And so we're going to be talking about this today. Before I hand over to my colleague, Kyrillos Sawiras, who is a solution architect, I also want to let you know that I am going to be, I'm going to share my contact details at the end of the session today. So if any of you would like to have a further discussion, or if you'd like more detailed information pertaining to your organization, you can just reach out to myself. And Kyrillos and I would be more than happy to kind of, meet with you and work with you. So with that, I am going to introduce my colleague. We work very closely together. So Kyrillos is a solution architect at AWS. And so he focuses more on the technical aspect and provides the architectural guidance on your cloud journey. So welcome, Kyrillos, and I'm going to hand over to him who will be running the presentation today.
Hello, everyone. Good morning. I'm based in Ireland, and I work closely with Islan and with all EMEA customers. I'm a solutions architect. I work again with customers from all over the world, and I'm happy to be here today and present the cost optimization and how you can save cost in AWS. So let me share my screen and we can get this started. I will stop the video so that I can save some bandwidth, but yeah, I'll come back. Okay, so let me know if you can see my screen.
Yes.
That's great. Thanks. Thanks, Arnold. So, okay, let's get started. Good morning, everyone. Again, this will be around cost optimization on AWS. This will be around 40 minutes presentation or maybe less. And then we will be opening the floor for questions. Please feel free to pop up your question in the chat and we will be address them at the end. So let's start by covering the agenda for today. So today we are going to talk about how to optimize your cost on AWS. We will cover the total cost of ownership and cost optimization framework, and finally the modern TCO comparison. We have a lot to cover, so I'll be going quickly through the slides and we'll focus on some examples and scenarios that I prepared. It's always better to focus on the scenarios and the example rather than focusing on the theory, but again, I'll cover both and trying to give more attention to the examples. So total cost of ownership. So total cost of ownership maybe is one of the factors that we speak to our customers about while adapting AWS. We start the conversation with TCO, or total cost of ownership, and simply it's a comparative to total cost of ownership analysis. So it's at the end of the day, it's analysis, and it compares the acquisition and operating cost for running your application workload end-to-end on-premises versus AWS. In AWS, we have tools to assist you build the TCO and build the business case for adopting the cloud or moving to the cloud. We have the AWS pricing calculator. We have migration elevator, formerly TSO logic, and we have also some of our partners that provide the same service like Cloud Chomp. Okay, but what are the initial questions that you need to ask, or we will be asking you in the TCO? So I have them here. I won't go through them each one, but just to give you an overview. First, we need to speak about the capacity planning. How to plan for capacity? Can you switch your hardware on and off and pay for what you used? We start with capacity planning and see how the customer is hosting their application currently and how they are planning to host it in the future. We also ask about the utilization. Some of our customers will be maybe buying a huge server that they don't use, and maybe their application only utilize 10% of the application. So we need to understand the utilization when we speak about TCO and we speak about cloud. Operation, we need to understand where the customer are running currently, in a co-location, in a data center, in some small servers that hosting their application, or maybe in a cloud provider. So we need to understand how they are operating their application and their data center or co-location currently. Finally, when the customer takes a decision and decide to go to AWS, we work with the customers and try to optimize their cost. So I know that this is the second session, so hopefully in the first session, Islan covered lots of benefits and why you should move and host your application in AWS. So today we will be focusing more about the optimization. If you have, sorry, if you decided to go and host your application in AWS, how you can host the application in the most cost optimized way. And this is the main focus for today. And this is the second part of the presentation, which goes to optimization framework. So in AWS, we have something called well-architected or well-architecture framework. So this is a platform, this is a framework that help cloud architects build their architecture and align it with AWS best practices. So it allows customers to build and deploy faster. It allows them lower or mitigate risk, make informed decision, learn about the AWS best practices. So the well-architected framework is simply, it has guidance to how to build your application reliably, securely, and also cost optimize. And it has common design principles, as you see in the presentation. The framework work with our customer to stop guessing their capacity needs. You need to build for what you currently use and have auto scaling or have a kind of scalability so that it scales based on your need. It allows for innovation. Customers can focus on their application rather than focusing in managing their infrastructure. It helps also in driving an architecture that align with AWS best practices, and it helps you also build a test environment so that you can test your application before going to production. The well-architected framework is 5 pillars: operation excellence, security, reliability, performance, efficiency, cost optimization. And again, each pillar has guidance that you need to follow in order to make sure that you host your application in the best way in AWS. And it converts the general design principles that we have into a pillar-specific design principles. So that means, let's say that you're interested in security, so you can go through the security pillar and focus on all the questions. And once you finish the security guidance or principles, you can go for other pillar. So this was a brief introduction about the well-architected framework, and the reason I'm showing you today or speaking about the well-architected framework is we want to cover the cost optimization. We want to cover the cost optimization pillar and how you can optimize your cost in AWS. So we speak with our customers about the consumption model. So when you host your application in the cloud, you pay as you use. You don't need to say I will purchase one server and then I need to pay the capital expense or the operational expense for the server. No, you will be paying for your consumption. Our customer also should focus on having a cloud-first strategy, and that means they bring more workloads into the cloud instead of investing in their old data center or co-location. Using a managed services, they can use managed services to reduce the cost, and I will show you how during the presentation. And finally, you need always to analyze your spend with AWS budgets or Cost Explorer or any other tools that we will be covering today, so that by analyzing your spend, you know where are you spending and each service, how much it costs you. Okay, so these are the 4 main points that we will be covering today. We will focus on cost-effective resources, expenditure awareness, matching supply with demand, optimizing over time. So let's dive deeper in each point and see how you can optimize your cost. Starting with cost-effective resources, we work with our customers and introduce managed services. We work with them to measure their utilization so that they can have appropriate provisioning. We help the customers to have right sizing on AWS. We speak about the different purchasing options and help the customer to choose the right region for them. And also optimize data transfer, maybe by introducing a service that can optimize the cost of data transfer. So we will now dive deeper in each point, and I will have some examples to show you what I mean. So let's start with managed services. In AWS, we have lots of managed services. Customers use managed services to allow the innovation faster. They using managed services also offer lower cost. They are maintained by AWS. You don't need to have lots of engineer or IT team to manage them. And you can also reduce your license cost by adopting managed services. And in terms of managed services, in the compute options for AWS, as you see, we have lots of options for you, starting from EC2, which is just a virtual machine in the cloud, Elastic Beanstalk, which is a platform as a service or a way that you upload your code and then the service will be managing or the service will be launching virtual machines, load balancer in the background for you. Elastic Container Service and EKS Elastic Kubernetes Service are the service responsible for building Kubernetes or container clusters. AWS Forgot is a serverless way to host your application in a serverless container. And finally, AWS Lambda, which is just a function as a code, a function as a service. You upload your code and the function gets executed. So when we work with our customers, we tend to tell them, okay, we have lots of compute options, but which one you want to choose? And you need to have the decision based on the managed or non-managed, and pay for the infrastructure or pay for transactions. So some customers want to manage the virtual machine, want to see the virtual machine, want to have the operating system updated by them, want to have some security patches done by them. So in such case, they will go for EC2 or Amazon Elastic Compute Cloud. And again, it's unmanaged. You pay for the infrastructure. And some other customers will choose to be in a serverless way with AWS Lambda. And with AWS Lambda, it's a highly managed service. So you just upload your code and that's it. And in such case, because Lambda function is not running 24/7, it only runs when there is a trigger. So you pay per transaction or pay per execution. And the same apply for databases. So we have all the options for you to host your database, either to host it in Amazon EC2, Amazon Relational Database Service, Amazon Redshift, Amazon Aurora, or Amazon Athena. And these services, again, allow the same concept, unmanaged and highly manageable, pay for infrastructure or pay just for the query that runs on your data. Again, the same for NoSQL. You can host your NoSQL option or database in EC2, or you can use a managed service like DynamoDB and DocumentDB. Like don't focus with the services itself. I just want you to focus on the concept that we have all the options, either to run it yourself with a virtual machine or to use a managed service like DynamoDB and DocumentDB. We will be not focusing on the service, except in the examples. I will be showing you some of the useful parts. And finally, with the messaging, if you want to build a way to have a messaging queue between your servers, either to host it again in EC2 or to use a managed service with AWS like Amazon Simple Queue Service or Amazon MQ. And again, you choose between you want to manage them or you won't manage them. So you want them highly manageable. You want to pay for the infrastructure, or you want to pay for the transaction and for usage. The takeaway from this pillar is you need to ask yourself what service you can use and which one can be replaced with an AWS managed service. Next is appropriate provisioning, and this is a really important pillar. Choosing the right application architecture can save you a lot of cost, and you need also to identify the service capacity that you need. So as you see here, you need to have some data about your application. Steady state application, that means that your application will be maybe running 24/7. It just runs on a very constant way. You know that you will only have, let's say, 100 users per month, and they won't change over time rapidly. They might change in the future, but you have the steady state base. or maybe your workload is bursty, so maybe you have 1,000 requests today and tomorrow you will have none. So it depends, and having your workload from a steady state to bursty workload can it change your decision in having the architecture and choosing the appropriate messaging and the appropriate architecture. So you can also work to consolidate some databases into one table, and you can choose between cost and performance. And there are trade-offs. So also we have the serverless way. So the serverless way is when you host your application with no servers, and this allow you to have flexible scaling, high availability, and no idle capacity. And there is also an example during the presentation that shows you how to choose serverless versus how to choose server. And here it is. So we have here two scenarios. Let's say that one of the customers want to have a constant steady state application workload. Let's say they have 16 concurrent processes, and each process running around 512 megabytes of RAM. And we have another scenario that the customer will have a bursty HTTPS-based API service. They are expecting 600K requests per month with 200 millisecond latency and 128 megabyte memory per request. So how the customer will be choosing either to use server or serverless? Let's see how they should choose. So we start with a comparison. First, the first scenario, the customer had a steady state application. So the customer choose to run on EC2, which is the virtual machine or the compute service that we have. So they will be paying this amount for the EC2, and they multiplied here by 730 because they will be running 24/7. So we will say that in each month they will have 730 hours. So this will be the price for them if they go for EC2. But what if they decided to do the same with serverless? Let's see how much they will pay. So you see here they paid around maybe more than the double. And the reason is their use case in such case is aligns more into compute and having the virtual machine running in a steady state for 24/7. But when you have the same with Lambda function or API gateway or the serverless services, these are the serverless services, and they are not the best option if your application is a steady state and it needs to run 24/7. You see here we had to multiply by 730 hours, and that's why you will have here this amount to be paid. So in such case, you need to host your application in EC2. But what if the second scenario, if you remember the second scenario, we had a customer who said, no, my application is not constant, it's not steady state, it's bursty HTTPS application. I'm expecting 600K requests per month, and I need this amount of memory for each request. So in such case, if the customer choose to host this application in EC2, they will be paying this amount, $140 per month. But what if they decided to go for serverless? They will be paying just $2. And the reason is the use case that the customer mentioned, that they have a non-constant and not a steady state workload, and they will have just 600 requests, 600K requests per month, and each request just need this amount of memory. That is the best use case to use Lambda and API gateways and these serverless solutions in AWS. And when you use them, you save a lot of money, as you can see here. So apparently in the first scenario, when the customer has a steady state application, they should go for EC2 or virtual machine, and they manage it and run it 24/7. But if they have a bursty application and they can host it in a serverless way, they must host it in a serverless way, and this will save them a lot of money. Another example, when you want to store some of your data, some of our customers ask us, should we store them in Amazon S3, which is an object storage service, or should we store them in Amazon DynamoDB, which is a NoSQL database that can store semi-structured and and unstructured data. So in such case, we work with the customers and understand their use case. So let's see this example. In this scenario, we have a customer and they told us our application makes high number of writes per second, and we want the best the most cost-effective solution in AWS storage. So these are the requirements. The customer has 300 write per second. This is the object size, 2 kilobyte. This is the total size that they will be saving or storing each month, and this is the number of objects. So in such case, if the customer choose to use Amazon DynamoDB or our database or NoSQL database, here is the amount of data set. So they will be storing this amount each month. And here is the amount, or this is the size of the object. And finally, this is the request rate, or they will have 300 writes per second. And if they want to compare the price between Amazon DynamoDB and Amazon S3, they will be doing that. So they will go to Amazon S3 calculator, and they will be hosting and trying the AWS calculator. So here is the storage. This is the amount of storage that they will be hosting. And this is the number of objects and the put request to save and to upload the objects. And now let's see how much each one will cost. So the first option, when you store it with DynamoDB, this will cost you around $644 per month. But with Amazon S3, with this use case, you will be paying around $4,000. And again, this is one of the points that you need to decide when moving to the cloud, and when you host your application in a cloud provider and AWS, you need to have the appropriate architecture and the appropriate provisioning. Okay, so some use cases can cost you a lot more if you choose the service wrong. But what if the same example, the customer changed the requirement and they will be having each object size to 32 kilobyte? In such case, you see, we'll go again to the AWS S3 calculator or the AWS pricing calculator, the new calculator, and we will be trying to estimate the cost. So the total size here for the data set, we have it, and so it's also changed, and also the object size is changed. And in Amazon S3, we also changed the storage and the number of requests. And let's see now how much you will be paying for each option. So you see here, with these changes, when the customer changed the object size from 2 kilobyte to 32 kilobytes, they will be paying in Amazon DynamoDB around 10K. But they can save money and store these objects in Amazon S3 and only pay 4K per month. So again, these are the points that you need to focus on while designing your application and choosing the right service. So apparently, option 1, the customer will need to use DynamoDB, but with the option 2, they need to use Amazon S3. So the takeaway from here, you need to select the right architecture and associate it with the right AWS service. Okay. And moving on to the third point, which is right sizing. With right sizing, we work with customers to use the lowest cost resource, and we help them adjust the size of resources and monitor also these resources over time. So for example, with Amazon EC2, always try to identify the right size instance before going for reservation. This is a rule. When you speak with AWS, we will always tell you, work for maybe 1 month or 2 months and see your utilization and see your consumption, and then think of reservation. Don't start from reservation. you need to know your right-sized instance first. And here is actually a good example. It compares smaller instance versus larger instances. So let's say that we have a customer and the workload is similar to what we are seeing now. Let's say that they host this application or this workload in a 29 M5 large. So M5 large is one of the memory optimized instance that we have. They will be paying around $2,000 per month. But if they choose to host the application in 59 T3 medium instance, they will be paying around $100,791. So you can see here there is a cost optimization opportunity for the customer if they choose to run more smaller instance rather than running fewer larger instance. You still can save money. So also for the Lambda function, so again, the serverless, you can also save money with serverless and do optimization with serverless. So you can do performance test. You can check if your function is memory bound or CPU bound. You can also monitor the function and test its performance and also minimize the deployment size. So if you can achieve this recommendation, you will be saving money with Lambda. Also with Amazon S3, which is our storage service. Inside Amazon S3, which is our object storage service, we have lots of classes: standard, infrequent access, one zone infrequent access, glacier deep archive. Standard infrequent access and one zone infrequent access are real-time storage tiers. Glacier and glacier deep archive, they are near real-time storage tiers. And you need to decide if the objects that you will be storing in Amazon S3 are frequently accessed or infrequently accessed. So here is an example. You see, you will be paying for the storage pricing, the request pricing, the retrieval pricing, and you won't be paying any retrieval pricing for the standard, but you will be paying retrieval pricing for the standard infrequent access, one zone infrequent access, glacier and glacier deep archive. And the key points here is store your data in infrequent access tier is 50% cheaper than standard tier only if the objects are infrequently accessed. And here's an example. Here's an example to make things clear. So let's say that we have a customer. They have 1,000 objects. Each is 1 GB in size, and they will store it in Amazon S3. We have 3 scenarios. The first scenario, every object is retrieved once per quarter. The second scenario, every object is retrieved once per month. The third option is, or third scenario is each or every object is retrieved once per day. And the customer is asking which storage class they should use. So let's see the comparison here. In the first scenario, if the customer chooses to store in Amazon S3 standards, they will be paying this amount. But if they choose to store it in S3 infrequent access, they will be paying less. And this is because the object will be retrieved once per quarter. In the second scenario, so again, here, you should choose the S3 infrequent access. In the second scenario, where each object is retrieved once per month, you won't find any difference, like really small difference here between the standard and the infrequent access. In the third option, actually, when you have the object accessed or retrieved once per day, if you choose to store it in Amazon S3 standard, you will be paying around $400. But if you choose to store it in infrequent access, you'll be paying $4,000. So again, you need to understand your requirement. You need to understand your objects, if they are frequently accessed or infrequently accessed, and based on that, you can choose the right service and the right class for your use case. So again, apparently, in such case, you need to use S3 standard, not the S3 infrequent access. Again, this is the rules that you can follow. If you're retrieving an object once per month or more, standard is more cost effective than the other infrequent access classes. And if you don't know the pattern, choose Amazon S3 intelligent tiering. So this is a class that will be moving your objects between the different classes based on the usage. The takeaway from here is you need to understand your workload and design it with right-sized instance or right-sized infrastructure. And the purchasing option also is one of the points that we help our customer with. So purchasing option for Amazon EC2, we have the on-demand pricing, and also we have some discounted prices with reservations. If the customer will, let's say that the customer will reserve for 1 year or three years, they can get up to 70% reduction in their cost. You have the on-demand, the reserved instance, the spot instance. On-demand, you pay per second or per hour. Reserved instance, you reserve for 1 year or 3 years, and you get 70% saving. Spot instance, you can get up to 90% saving over the on-demand price. And spot instance are the spare capacity in AWS, and AWS has the option to claim this capacity whenever they want. So if you designed your application to use a spot instance, you need to design it for failure and tolerate any failure, because maybe the instance can be claimed by AWS. With DynamoDB also, the NoSQL database, you have provision capacity, on-demand capacity, and reserved capacity. With reserved capacity, you can save up to 87% with a 3-year commitment. So this shows you that there are different purchasing options for you that can help you. Again, for if you commit for 1 or 3 years, you can save a lot of money. The takeaway from here is look across your AWS infrastructure for opportunities to optimize the way in which you purchase services. And next, we will speaking about matching supply with demand. So first, we'll start with demand-based. What if you have a spiky application? How you can design it in AWS? So you need to have some sort of auto-scaling, and this will scale based on the load. Let's say that auto-scaling will be attached to alarm, and this alarm will be monitoring the CPU utilization of your machines. If the CPU utilization is, let's say, more than 70%, you want to add more servers. This is what we mean by demand-based. So this is an example. You see here, we are using auto-scaling group to adjust the capacity for your application. So that means that you only design your capacity for the base and what you are expecting, and leave the auto-scaling group to scale based on the usage and based on the CPU utilization or memory or number of requests or whatever metric that you want. And we also have another auto-scaling concept, which is AWS Autoscaling. It's a service that helps you to auto-scale even more services like DynamoDB and so on. The takeaway from here, look across your workload and consider the metrics that you want to use for auto-scaling so that you can ensure the capacity is closely aligned with the demand. Some other customers, they have some requirement to have time-based auto-scaling, and in such case, we work with the customers and provide them with other tools to help them. So for example, here, this is an example. Let's say that you have running time similar to the example here. You can save up to 70% if you know when you need more capacity. And for example, this is another diagram that can show you. So we can say that you estimate that your workload is just 10 hours usage per day. So you'll only have 10 hours usage, and you leave a service or a feature like AWS Instance Scheduler to provision more capacity at a specific time. Let's say that you know that Monday morning you will have lots of engineers or lots of people joining or using your application. So you can have instance scheduler to scheduler and to add more instance, maybe Monday at 9 a.m. And then you can stop these instance after 2 hours or 3 hours using the instance scheduler. So this is what we mean by time-based. So the takeaway here is you need to identify the workload that you don't need it to be running 24/7. And believe me, that will save you a lot of money. The next is usage and expenditure awareness. We have the tools in AWS to help you have expenditure awareness and seeing each cent you are paying in which service. So we will be covering tagging and visibility and governance now. So with tagging, you can tag your instance or your resources with the projects. So I'll just skip this slide and show you the example directly. So here is an example. Let's say that you have finance, engineering, line of business owners, IT, security. You can create tags for each stakeholder, and you can filter resources based on tag and see, for example, how much the engineering team cost you this month, or how much the IT team cost you this month. And this is the benefit of tagging. You can create tags by using a service called Tag Editor in AWS. You can choose which server or which service is belonging to a specific tag, and you can just click and tag them with your value. Once you have tagging, you can enable cost allocation tagging, and that allow you to get a detailed cost analysis for each of your tag. Again, so if you have a cost center, for example, for finance, you can know how much they used AWS for. The takeaway here is always use tagging, and also use AWS Identity and Access Management to control and enforce tagging policies. And with visibility and governance, again, AWS has a lot of tools to allow you see your usage and see your spend. I will be covering some of them in the next few slides. So the first one is Cost Explorer. With Cost Explorer, you can see how much you are spending each month. You can see the trend. You can see the forecast for each month. You can see how much you are spending in each service. And like, as you see here, it's just a dashboard, and you do some filters and you see how much you are spending. You can also get the benefit of ROI recommendation. So inside Cost Explorer, there is a tab called Reserved Instance Recommendation, or ROI reservation. And in this tab, you will see the recommended approach from AWS. For example, they can tell you you can save, for example, $1,000 per month if you purchase this instance for 1 year or for 3 years, and you can then see. So like, this will give you some recommendation. We have also another service, a really useful service, which is AWS Budgets. AWS Budgets help you to identify each project and how much they cost you, and you can create an alarm and say, I don't want maybe finance to spend more than 1,000 or maybe $500 per month or per year. And based on that, you will receive a notification that says, look, the current utilization for finance is X and the alarm is Y. So you can work with them to either close or terminate some of the resources. And finally, Trusted Advisor, which is a really nice service in AWS. It gives you recommendation to how to save cost, how to improve performance, to how to add security, and how to design for fault tolerance and also for service limits. The takeaway, always monitor your resources, not only in the first months for adopting AWS or adopting the cloud, but after that, and keep monitoring your resources. Optimizing over time, this is actually what I was saying. You need to keep monitoring over time. Monitoring shouldn't stop when you just start with evaluating AWS and you spend your first months monitoring the resources and adjusting everything. You should keep an eye and have a team or have an engineer or have someone to keep an eye on your cost. So that can save you a lot of money. And again, this is the main point for this pillar. Over time, you need to continue monitoring the resources so that you can see the performance, the cost optimization opportunities that you have. And the takeaway here is have this ownership to be assigned to maybe a team or some people in your organization to monitor the utilization and see and search for opportunities for saving. And last part is in today's presentation. I know we are close to 40 minutes, so I just need 2 minutes to finish. Like how to optimize the TCO in AWS. And this is actually a really nice slide, and I want to spend just 2 minutes on it. So the traditional TCO, or total cost of ownership comparison, you compare how many servers you have in on-premise, and you say you will have, let's say that you will be having the same servers with the same requirement in AWS. So this is called lift and shift. You lift and shift all these resources and put them in AWS. So this is a comparison between Apple and Apple. You say I have one server, and this server is X amount of CPU, X amount of memory, and you want the same server in AWS. So this is an apple-to-apple comparison. But again, this is the traditional TCO, and the modern TCO comparison shouldn't be an apple-to-apple comparison. But you should introduce right sizing. So if your utilization is 10%, you should be choosing the right instance, the right sized instance. You shouldn't just go and maybe have the same instance type in AWS. You should also check for elasticity. You can scale, you can use auto scaling group or instance scheduler to scale and just have your instance with lower CPU and lower memory because you don't need them 24/7. You can also optimize the cost for your storage, and then you will have an optimized lift and shift. And when you compare the on-premise to the optimized lift and shift, you will see a lot of saving. But some of our customers want to stop on the optimized lift and shift. They will keep optimizing. They will measure and monitor and improve their environment. They will use managed services. And when you do so, you will have the AWS optimized approach. And when you compare the on-premises approach to the AWS optimized approach in the TCO, or the total cost of ownership, you will see that you will saving more money. But not only that, finally, you can go for serverless. And when you design your application in a way that it handles serverless queries, you can save way more. As you see in the first example, you could pay $140 for one of the application per month, and the same application, if this is the right use case to use serverless, you can pay just $2. So you can see how much you can save with adapting serverless architecture. So actually, that's all from my side. I wanted to explain the traditional TCO, how you can have a more optimized TCO, and that's it for today. Again, thanks for your time. Thanks for attending today. It was a pleasure, and we still have time here to open the floor for questions, and we can be answering the question myself and Islan in the next few.